So as you've heard all conference, Kubernetes is clearly a huge focus for the Spring teams this year. Let's hear from Brian and Stéphane now about some of the specific ways that the Spring Boot team has embraced it.
Hello, welcome to this session. Stéphane and I were both committers on the Spring Framework and the Spring Boot projects. And today we're going to talk about how Spring Boot loved Kubernetes in the context of Spring Boot 2.3. Don't forget to join the dedicated Slack channel and ask your questions there. We'll monitor that channel, and we'll answer those questions during the Q&A sessions right after. So we do have a safe harbor statement because near the end of that presentation, we'll have a few forward-looking statements, and not everything's 100% sure yet, but most of the presentation is already in milestone phase right now, or released. So we're going to talk about how Spring Boot loves Kubernetes, but we're not going to talk how Spring Boot is tied to some Kubernetes implementation details, or you don't really need to know how Kubernetes works and how you're supposed to deploy it or maintain it. But this is more about how Spring Boot is adopting the best practices of Kubernetes and how you can reuse them in a typical application. So depending on your deployment, it might be Kubernetes, it might be another platform, it might be on-prem with a custom-made system. It doesn't matter. Those concepts are mostly useful to all those deployments, and you'll see why. We're adopting those best practices, and of course, what we want to do at the end of the day is these concepts should be useful to everybody, but at the same time, we want them to be naturally available and naturally present whenever you deploy a Spring Boot application to Kubernetes, and we'll show you that how.
So the agenda for the presentation today, don't worry, we don't have too many slides. We'll quickly jump to live demos. We're going to work on a scribe application where we're going to showcase various topics around Kubernetes best practices. We'll start with efficient container images. We'll show you how you can build optimized images. Then we'll talk about liveliness and readiness, graceful shutdown, and then we'll finish with some new features coming up in Spring Boot 2.4. So the application we're going to use is a Markdown editor with spell check. So we have one app on that serves the front end where you can write some text. Then this text is rendered to Markdown. And we also have, as you can see here, there's a typo. We also have a spell check that tells you about, very simple, the words that are misspelled. So we do all that because we want, of course, to showcase a distributed system with a very, very simple approach, so we can focus on the concepts and not really on the domain. So we have the Scribe application, which has a web UI, the spell check, and to render the text, it's going to call a Markdown converter application. And it does so, as you'll see later, it does so with a fallback. So if the Markdown converter is not available, then we have a degraded output instead of the markup being rendered. And we have a separate application to do the rendering only.
Okay, so right now we're going to talk about the first theme, which is building efficient container images. So we're going to start with our application in the IDE. So we've got both applications, the Markdown converter, but we're going to build mainly the images for the Scribe application, which is the first one with the web UI. So once we've got our application ready and we can build it, there is now the opportunity to add a Docker file to our IDE. And the simplest version that we could add is this one. So this is like a universal almost way to run applications with executable jars. In fact, so if you have that Docker file in place in your project, you can build this image with Docker build. So right now we're building it under the scribe custom application name, and we'll see why later. So you run that, it's building the image with the local Docker daemon. And then right after, you can run the application on port 8080. And as you can see, here we're running the app. And we even have some text in the application at startup saying that what type of operating system we're running on and some property. So this is the simplest way to build a container image for our application. And now we're going to dive into it. So the dive, we will have a reference on our slide. It's a tool to explore how a container image is layered and how it's composed. So do you want to comment those layers?
So the problem with this approach is the layer of the app, you only have one layer, right? This is the application itself. So whenever something changes in the app, be it like you've implemented a short bug fix or you change some part of the configuration, then the full layer needs to be recomputed. So it's not very efficient. So let's see how we can improve that using the Docker infrastructure. So I'm going to, right below this Docker file, actually paste another approach. So this approach is to use a multi-build step where we, rather than actually putting the application jar itself in the layer, we extract the application jar and then we create layers manually. So in this case, we can see that we first extract the application jar to a source directory, and then we reuse that to create 3 layers, one for the libraries, one for the meta information, and one for the classes themselves. And this approach forces us to actually run the application using some extra information. So for instance, we have to know the fully qualified name of the app and build a class path ourselves. So actually, let's
build that.
Yeah.
So since we've separated data into layers, it makes things a bit better from a Docker and container image perspective, because instead of rebuilding the whole application layer every time, we can only rebuild the layer that's been changed. So in our case, the classes of your application tend to change more often than the Spring Boot version that you're using. So if we dive into that container image, we can see that the last layer is the one that is the most likely to change often. And before that, we've got the dependency, the libraries, and so on. So this is the way to optimize a bit things. But as Stéphane mentioned, it's a bit more complicated to operate into your Docker file. And also, we've lost a bit some knowledge about the class path, because right now we're just giving a whole directory to the Java command line as class path, and depending on your application, class path ordering might be important. Usually, it's a bad sign, but still. And here we're losing that information when we're extracting all the files. So it's almost the same, but we're losing some information.
So something that we could do. Let me actually paste. This version, which is a bit improved. Actually, moving too much stuff here. So this version is actually, rather than extracting the 3 layers and then creating a structure so that you can build a class path and everything, the idea is to reproduce the structure of the fat jar, but in an exploited fashion. So you could see here that, for instance, the libraries are copied to a directory called boot in flim, which is the same structure that you'll find in the application jar. There is also a class path index here that's being copied manually. Let's go back to that in a minute. Then there is an org directory for org spring from a boot, and that's where you'll find the classes of the launcher. So when you invoke a Spring Boot application using java-jar and your jar, actually what starts is not your main class, but a launcher from Spring Boot that knows about your main class, and it will prepare the infrastructure and the class path for you. And of course, the command now is much more simpler because what you do is you invoke that launcher, and that launcher will read the meta information and execute the app.
Yeah. So to summarize, go ahead.
Sorry, this index file is actually the list of the class paths in the order that was used by your build system. So you have the guarantee that when the app starts this way, the order of the class path is maintained.
So to summarize, with that approach, which is still a bit more verbose than the initial one, we're technically super close to how Java-jar works with Spring Boot applications. So class path ordering, the jar launcher, etc. We're a bit faster at startup time because we're exploding the jar already on disk, which is a bit faster, and we're more efficient when it comes to Docker or container images with regards to the layers. So as we can see here, we've got several layers, one from each copy statement in our Docker file. So with the jar launcher, classes, and the actual code of your application in the right order. Ordering is really important here because you're supposed to order things that are less likely to more likely to change during the application development.
So of course that works, but we could do better because in your Docker file there's too many information you have to know about the internal structure of the file. For instance, you have to know that there is a class path with IDX file that the launcher is going to use. You have to know about the package space for the launcher. You have to know about the main class for the launcher. So maybe we can improve some of those and actually provide these dedicated concepts about layering. And that's what we have in Spring Boot 2.3. So as of Spring Boot 2.3, you can enable a mode that's called layered jars, which will help you to simplify your Docker file. So let's see that in action. So we need to opt in for this. So there is a layers configuration where you need to opt in for this and enable that mode. So we need now to rebuild the app. Is it a value that works better?
Yeah. So this is working with both Maven and Gradle in the repository that we'll be sharing with all the sources of that demo. You'll have both Maven and Gradle examples in the same repository.
So once you've enabled that mode, there is a way to use your application jar in a different way. So there is an extra option called jar mode. And as you can see now, I've opted in for the layer tools mode. And what it does, it allows me to list the layers and interact with the layers. So for instance, if I list them, then I can see that this jar actually split the content of the application in 4 layers. There's dependencies, which is basically all your dependencies. Spring Boot loader, which is which contains the loader, so that you don't have to remember about that old namespace. Snapshot dependencies are actually likely to change more often, of course, than GAs. So we have a dedicated layer for that. And then finally, the application, which is your classes and resources.
Mm-hmm. So this represents the opinion of the Spring Boot team when it comes to a generic Spring Boot application, and we'll see how that translates into a container image.
So one of the options of this mode is to use extract. And if you invoke extract, what it's going to do, it's going to expand the application jar in such a way that it's much easier for you to compose layers in your Docker file. So let's have a look to that. So in the Docker file here, I'm reusing the command I was showing earlier. So rather than extracting the application jar myself, I'm actually using the layer tools mode to do so. And rather than having those concepts that you have to know about, resources will be already located in a folder with the name of the layer. So you have a folder for the dependencies, a folder for the loader, folder for the snapshot dependency, and finally the application. And as previously, you use the jar launcher, which knows where to find the meta information to store the app.
Yeah, so we're making progress. We don't have to know the inner structure of the jar. Spring Boot is taking care of that for us. We still have to know about the different layers, but it's quite easy with the jar mode, and we just have to get the order right. Otherwise, we won't get as efficient images as we can. And in our dive binary, we can see all of those layers in action. So first the dependencies, then the loader, and again, snapshots. We don't have snapshots in that application, so it's empty. And we've got our application in a single layer.
And the metadata. So there you could find the class-path.index that's used to actually build a class-path property.
Right.
So those are the 4 layers that you get out of the box when you opt in for that mode. But we also provide a DSL so that you can compose those layers based on your own situation. So perhaps you have dependencies that are changing more often, or you'd like to structure the application in a certain way. So let's showcase that. And as we've mentioned, this Scribe is a web application, and this application is using web jars. At the moment, it's using only
one for.
Moment, let's assume we have more, and let's assume that those are changing way more often than the rest of the dependencies. We'd like to isolate those web jars into a dedicated layer.
So we're using that example to showcase how to do that with Maven. So with Maven, you can create a layers.xml file describing all the layers. So there's an XSD describing the syntax that you can use. So in that syntax, you basically, for each layer that the application provides, so here we've got application dependencies, you can check in some of the resources into a specific layer. So here we're getting everything under a Spring Boot loader into the loader layer. We're getting the rest of it under the application layer. As for the dependencies, we want to have something special for our application. So we don't really need something for snapshots here. What we want to do is we want to collect all the dependencies that start with the org webjars npm group ID, and all those dependencies will be included in the webjars layer. As for the rest, we'll regroup everything under the dependencies layer. And as usual, you still need to take care of the actual order of dependencies, and we have that in the layer order right below. So we've got dependencies first, because that's the Spring Boot version, then the loader and webjars and the application last. So once you've got all that described, you still need to tell the Spring Boot plugin that it needs to use that layers description to build the layers for our application. So here we're pointing with the configuration, this configuration item, we're pointing to the actual file, and rebuilding the application using Maven should create the layers as expected. So here we're packaging the application. We're in a layer as a layered application, and when we look at the jar mode, we see that now we've got dependencies, loader, webjars, and application as expected. And this will be reflected in the layers descriptor that is being shipped with the jar, and this is reflected as well when you try to build an image, because here, as you can see, it's failing. So it's better. We can customize whatever we want for layers, but we still need to maintain that one-to-one relationship between the Docker file and what we're configuring in our application. So still a bit of a manual process. We have to change and say, we don't have snapshots, we have a webjar layer, and this time we can build the app, and we can build the container image. And as you can see here, instead of an empty snapshot layer, now we've got a webjar layer with just our webjar dependency.
This is what you can do using Dockerfile and the layered index supporting Spring Boot. As Brian mentioned, this project has the setup for both Maven and Gradle. So if you're using Gradle, don't worry. We'll share the project with you, and then you can see how you can do exactly the same using the Gradle build system. But let's now go a bit further and show you how you can actually build an app without writing a Docker file yourself.
So for clarity, we can delete the Docker file from our project, and we can show you, and we're going to show you a different way of achieving the same thing, but without involving a Docker file in your project and involving those manual steps. So for that, we're going to use the build image goal of the Spring Boot Maven plugin. Similar task exists with the Gradle plugin. So once you've started building the image, you can see the project is being built, and then something's happening. Something is involving the cloud native build packs into the build of your project. It's checking out in container images that are going to be in charge of building the actual image of your project. And here we'll see that's a subset of build packs will be involved in building your application. So some will take care of choosing the right JVM, setting up the layers, configuring memory management for memory configuration for your Spring Boot application, and so on. There's a lot to unpack here, but still it knows about the layers.index file that we're shipping and all the metadata we're shipping with our jar, and automatically it's basically doing the right thing. It's building the image with the opinion that you expressed in your own build. So if we take a look into that image, so we can see there are way more layers. So the operating system is cut into several layers with opinions about security, where certificates are, how user management is done. So this has a lot to do with security and maintainability for your images, container images. But as for the application part, it remains the same as before. We've got our dependencies as a layer, and then we've got the loader, we've got our own custom layer, and we've got the application as well.
And we can of course start this app exactly as the other one. The name of the app is by default is using the artifact ID of the project. So I've used scribe custom for the Docker file. The application built using the build image goal of the plugin is scribe. And then we can see the app is starting as usual. Also, one thing is those build packs, they will actually react to whatever is actually configured, right? So you give them a source, and based on the input, so in this case, the Spring Boot application, they will detect things that they can contribute to the container. And some of those build packs are actually controlled by configuration properties. It reminds you a bit what auto configuration does. It gives you a default behavior with a way for you to customize that by specifying extra configuration keys. In the case of the build pack, it's quite similar. So one thing is the project right now is using Java 8. You've seen the JDK 8 being downloaded to build this image. Let's actually change that to switch to Java 11. So I'm going to, in the project itself here, switch to Java 11, and I'm simply going to rebuild the app. So we can see that the build plugin actually noticed that you've opted in for a different Java version. And so it communicated that to the build pack automatically. And now the image is built with Java 11 rather than Java 8. The interesting bit is that's only the layer, that's the only layer that changes. So you can see that in the resulting image, Most layers are actually reused from cache. The only layer that's actually changed is the one which contains the JDK.
So there are a lot of things to unpack here. Cloud native build packs, it's just way more than a different way of building a container image locally. We've only shown that so far. It's actually closer to inversion control, where you have way more features. As you can see, you can express opinions in your application and it's reacting to them. You can enforce security requirements, best practices over a whole team or organization. It's built to have the most efficient container images as possible. And it's got a lot of features and a lot of concepts that we don't have time to go over right now. So please attend the Spring to Image session, which will be not in the next slot, but the one after. So check it out. Ben Hale is going to explain a lot of things about cloud-native build packs, the pack CLI, and as well the K8s Kubernetes service that goes with the project. So now we're going to our next part of this presentation. We're going to talk about liveness and readiness concepts. So liveness and readiness concept, we're going to first talk about the concepts themselves, because it may not be obvious what are those and how do we want to apply them into Spring Boot applications. Then we're going to show how it's complementing the existing actuator health indicator story that we had so far in Spring Boot. So as of 2.3, we've introduced more features around that. And third, we're going to show how you can not only have something automatically in your application, but how, as a developer, you can act on those concepts and on those states during the lifecycle of your application. So first, for the concepts, quickly, when it comes to liveness and readiness, in the past, I guess people were using the actuator health endpoint to do a lot of things, to tell the platform if the application is healthy, if it's ready to receive traffic, if it's broken or not, if it should be restarted or not. And here we've introduced two new concepts, the liveness and readiness concepts into the Spring Boot applications to really separate those use cases which are really different. So when it comes to liveness, we can consider that the state of an app is correct when its internal state is not broken. So the application itself might be having errors. External services might be breaking for some reason. So not everything might be working as expected, but the internal state of the application is fine. And liveness in that case is correct. Liveness is really considered as broken only when the internal state of the application, so this might be a local cache, this might be something that is really local to the container. And the only way to repair that is to restart the app. So this is the concept of liveness. When it comes to readiness, it's a bit different because there are only two states as well. It's whether you can be accepting traffic. So it's a way to tell the load balancer or the platform that you're ready to accept traffic. And you can be refusing traffic. It doesn't mean that the app is broken. It can just mean that your application is not ready yet. Maybe it's still starting. It can also mean that maybe the load on your application is too high. Maybe the application is currently processing tasks and so on. So this is synchronized with the lifecycle of both concepts are synchronized with the lifecycle of a Spring Boot application when it comes to startup and shutdown, and we'll show that later. If we go to the next slide.
Yeah, let's go with some demo here on that. So those concepts that comes from the Kubernetes world, of course, you can also apply them to your application if you deploy them with some other way. We're going to show you how you can enable that very easily. So to enable those probes, the only thing you have to do is to opt in for those And if your application runs on Kubernetes, if we detect that the application is running on Kubernetes, you don't need to add this property. It's going to be enabled for you out of the box. And what we want to showcase is what happens when you need to do something at startup that may take a while. If you rely only on the OS endpoint, and the application does something that's quite normal in startup, your infrastructure may believe that the application is broken and needs to be restarted. So that's where this difference between liveliness and readiness is quite important. And the way it translates in Spring Boot is via the lifecycle of the application. So for instance, in this case, we load the dictionary that we're going to use to do the spell check on startup. And for that, we use an application runner. It's quite important because using an application runner, we have to guarantee that the internal state of the application is flagged as being live, but not ready to accept traffic yet. And then we can invoke those. So there's a clear separation between the two.
So here that process is pretty quick. So if you want to demonstrate that, maybe we can add something that takes a bit longer.
Right. So let's have a look to first. Let me actually
the probe itself.
Split my screen here.
So here we're going to take a look at both probes. So those probes are actually health groups. You can check what are health groups in the reference docs. So they're just groups of health indicators, and by default they just have the liveness and readiness states as indicators. So right now they're both up when you run the application. And what we want to do is we want to delay the startup a bit. So what will happen is the application will be running, considered as live, because the server connector will be up, but the application is not totally initialized yet because our application runner is still running, initializing things. So it might be like populating a database, or in that case, pre-populating in memory something from a dictionary.
So let's rerun this.
So the app is down right now because it's restarting. Now we've got the liveness up, so the platform considers that the app is live, so it's not restarting it, but it's not routing traffic yet to the app, and now it is. So the platform will know in a simple way when and not to route traffic to the application. And on your side, if you use the Spring Boot infrastructure that we're offering for startup initialization and so on, the lifecycle will be completely in sync with those concepts, and you don't have to do anything special.
Something also that's quite important is using the OS endpoint to get an overview about your application and the dependency that it has versus whether or not the application is ready to serve traffic. So we've mentioned previously that the markdown converter caller is actually wrapped with a circuit breaker. And if the markdown converter is down, we got a degraded result. So it's actually the very simple degraded result here. So if I'm actually using the app, let's submit this. And then I can see the rendering, and actually we made a typo. So let's make one just for the sake of it.
All right.
Let's now shut down the converter and invoke this again. Then we get our degraded result. But if we look at the Earth status, then we can see that the global Earth status of the app is out of service, because one of the indicators actually tells us that one of the services that we use is not available at the moment. But that should not have an impact on the readiness, because we know we have a circuit breaker in place for this component. So that's quite important, and Brian is going to explain this why.
Yeah, so if you're pointing your platform to actuator health in that case, and since we've got our markdown render health indicator, In that case, the indicator is quite useful because we want to know what's happening with our application. But at the same time, the rendering service is not really required for our application. We've got a fallback for it. So if we point our platform to that particular actuator health endpoint, what will happen is the platform will consider that our application is unhealthy, and it will kill that instance. It will restart that instance. And the problem is, if all the renderer instances are broken, you're just going to you're just going to have a lot of problems and cascading failures into your platform. So in this case, the Markdown service is broken. So if you look at the health indicator, the global health status, it's out of service. But if you look at the individual liveness and readiness endpoints probes, they're both up. So in a case where an external service or another indicator is really important to liveness or readiness, you can, of course, add that indicator to the liveness or readiness endpoint, to that health group, and it'll be taken into account. But by default, we're not grouping all the indicators under those because we because we recognize it can be counterproductive in a lot of cases.
As a developer, you also have a way to declare that the application is broken and needs to be restarted. So that's what Brian mentioned previously with the ability to change the liveness of the application to indicate that the app is broken. So the way this works is, let's actually restart this. You have a way to control that programmatically. So it really depends on your app. Something that would happen when you communicate with some infrastructure, or when you read something from a store, or whatever might happen, where you would actually determine that the application can't be recovered and needs to be restarted.
In our case, we consider that during startup, when we're loading the dictionary of words, that's what we had previously. And here we're going to install some kind of tripwire into our application just to demonstrate that. Let's say your application is trying to check a word against the dictionary that we've got, and while checking against it, the application notices that maybe the dictionary is totally unreadable, or maybe the file system is broken in some way. And in that case, in our world, in this application, we consider that the best and fastest way to fix the problem is just to restart the application or another instance of this application. So as you can see, what Stéphane is doing is he's installing that tripwire. Whenever you type broken into the field, we'll check against that. And if there's a word broken into your text, we're going to change the availability event. We're going to send an availability event to our application. So this is a regular Spring application event. And we're going to publish that event using an event publisher. And we're going to say that right now the liveness state of the application is broken. So we're going to see how this works. So right now our application is up. We're restarting the app with DevTools automatically.
Yeah.
Oh,
so
we still
actually,
have
I did not remove the trick of waiting 10 seconds. Yeah. So yeah, we have to wait a bit for me to remove that. Okay, all right. So let's try it up and type.
You gotta be fast. 1, 2. Yeah. So sending that event will automatically change the state of the application globally, and calling the liveness probe will return down in that case. So of course, you can infer more information about the exception and so on. But here it's a nice way to control those states from your own infrastructure.
All right, so let's demo something else. Let me actually first remove this so that
the 10secs. Yeah.
Yeah.
Okay.
So this is a distributed system where the Scrub application is going to invoke the Markdown whenever you need to render something. And if you have like in-flight requests, when this backend needs to shut down for whatever reason, it's very important that you keep it running for a while so that those in-fact requests have a chance to be processed. As of Spring Boot 2.3, there is support for what we call graceful shutdown, so a way for the service to wait a bit for those in-fact requests to be completed. And this graceful shutdown feature is supported on every embedded web containers that Spring Boot supports. So let's see that in action. First, with the default behavior, you need to opt in for this. So the default behavior will be an immediate shutdown as it used to be with previous Spring Boot versions. So we have an extra trick in the backend here. If you write delay in the markup, the backend, so not the scribe application, but the markdown converter application, is going to take some more time to render the markup. So let's give it a try and write delay here in the text.
So here we can see it's taking a bit of time. And if we shut down, in that case, we got an exception on the scribe application side. So we're just displaying the fallback response that we have. So in that case, it's really unfortunate because we got an error response where, in fact, the Markdown application was just being shut down at that point. And it's not that uncommon in a platform. It might be a rolling update, so a new version being deployed of that application, or it might just be automatic scaling for that application. Maybe before we had many instances of that, and we have less traffic, so we need less. So application shutting down is not only whenever they break, but it can happen very normally over the course of the lifetime of an app. So how can we fix that?
Yeah, let's opt in for that. So there is a new server shutdown property, which defaults to immediate, and let's switch that to graceful. When we opt in for that, there is a grace period of 30 seconds that you can control. So there is also a property where you can increase or decrease the grace period depending on the use case.
Depending on the server, some servers have different implementations for that. Some are refusing connections. Some are returning a specific HTTP status to say that they're not accepting traffic. But in the end, load balancers should know how to behave in those cases.
So we still have our delay here. So let's submit that again and shut down the server. Then we can see that in this case, there is a graceful shutdown that's being applied. The application is still running. Then we can see after a bit, it's actually shutting down. And if we go back to the preview, we can see that the request completed successfully.
So in that case, the application is processing all the ongoing requests and just not accepting new ones. But we're less likely to see those error messages and unfortunate responses when an instance is just shutting down. All right, so now it's coming the time where we have some forward-looking statements. So some of these things are already in master, some not yet. So just bear with us about that. First thing that we already added is the config file processing. So previously in 2.3, we're already supporting some of it, but now we're doing much better with volume-mounted configuration trees. So here you've got an example of a way to configure a volume-mounted configuration tree of files. So the key name, the name of the configuration property will be the file name, and the content of that file will be the actual value. And so as you can see, that feature is bringing way more. So there's a way to activate optionally or on some conditions the imports or some parts of your configuration. And in this case, we're only activating that in case of Kubernetes deployment.
And you can see that in the import statement there, so the spring.config.import, there is a config tree, which is one of the options that you can use to add additional property to the environment. That prefix is actually used by a dedicated implementation. You can add more implementation. As a matter of fact, there are more implementations that are available in Spring Boot 2.4. So check out the blog post for more details about those options.
Oh yeah, right. We've got also, this one is not done yet. We're thinking about improving the graceful shutdown approach right now. When you're configuring the graceful server shutdown, in our reference docs, we're advising people deploying on Kubernetes to add a pre-stop hook, which is basically a way to tell Kubernetes to wait a bit before actually starting the shutdown process of the application. So this is a way to give some time to the platform to update its state and not route traffic anymore to the applications, to that instance being shut down. So this is something that we advise right now, and in the future we might add an option to basically include that delay into the application itself. So we might have another grace period where we accept still incoming requests, and then we would enter the graceful shutdown phase and would be refusing new requests. So this is being discussed in a dedicated issue, and this might be done in the next release, 2.4 release of Spring Boot.
And finally, and that one has been implemented. So at the beginning of the demo on layer jar, you've seen that we had to opt in for it. So we had to add this enable flag to get these layer tools and the creation of those layers. So you had to opt in for it in 2.3. In 2.4, you don't have to. So in 2.4, that's the default behavior, so that you can create optimized image regardless of the technique you want to use. And that also brings more features out of the box.
So I think we're done with the main content of that session. You can join us, if not already, on the dedicated Slack channel and ask questions there. We'll be there on the take a look at the channel, and we'll there'll be a link to the Q&A session right after that. Don't forget to check out the Spring to Image session with Ben, and don't forget also to get the links. We'll post the slides on the session page, and the code is there on GitHub.
And the code also has one commit per demo, so you can go back to a specific demo, and then if this is related to the build system, the commit will show you both with Maven and Gradle how to do it. As for the slides, they will have more content than the one that we've been sharing with you today. So there's a bunch of skipped slides that shows extra information if you want to dig in more detail into those concepts.
All right, I think that's it for us.
Thank you.
Great. So for all of you working with Spring Boot and Kubernetes these days, those features are absolutely going to be game changers for you. Starting now, we have a Q&A session, so you can ask Brian and Stéphane any questions you have about this stuff. To join that Q&A, click on the Zoom link in the breakout Slack channel, and you'll be taken directly to the Q&A area. If you don't have any questions, go ahead, take a break, refresh your beverages, and come back for the next session in a few minutes. Thanks.